going to talk about network security from a very low-level point of view, from the network point of view. This is pretty generic stuff. You can apply it to a 2110 network, to an enterprise network, to the components in a WAN, whatever you feel like, right? Please feel free to jump in and ask anything that I've skipped across in a way that you prefer I cover more deeply. Going to talk a little bit about what network security is. Everyone's heard of zero trust, right? I'll not tell you what that is. Talk a little bit about physical security, basic security that maybe everybody should be doing, and then some kind of further advanced stuff, more advanced stuff, network segmentation, access control, network detection response, and I'll give you a summary. Now, I was a little bit worried about the basic network subject matter, because I wasn't sure exactly what everyone else was going to talk about. I actually think this fits quite well. And I'm actually really quite pleased to go last now, because there are a whole bunch of little bits and bobs I can pick up on that have already kind of been talked about, okay? So I thought I'd better check what Wikipedia thought network security was. And, I don't want to read my slides out, but I'm going to read this. So network security consists of the policies, processes, and practices adopted to prevent, detect, and monitor unauthorized access, misuse, modification, or denial of computer, network, and network accessible resources. So I think it's always worth trying to understand the problem statement, and I think that nails it pretty well. The network is a thing that connects things together, and there are things that you don't want to be connected together, like baddies and your network. And you built your network to do a specific thing, and you don't want other people to be using it to do things you didn't want, or to be stealing stuff. So there's a list here. We've kind of covered a lot of this stuff. Media content theft, we've heard about that one. Confidential data theft, we've heard about that one. Encryption and ransomware, that was kind of pretty heavily talked about. Misinformation. I mean, if you're running a TV station, perhaps somebody injecting a whole load of stuff into your feed on the way out, maybe that'd be something they're aiming to do, right? So it's not just stealing stuff, it's pushing stuff in. Denial of service, we heard about that just now, right? Taking the Queen off air. So these are all real things. I was surprised by that 42. I've said that already. Really surprised by how high that number is. But I guess maybe this is happening more often than we think. And computing resource theft. I mean, I guess what I mean by that is somebody can get into your system and use your resources to do the same thing again. So there's a gain function there. If I can get in here and steal all their compute, I can then use all their compute to do something else somewhere else, right? So there's a whole ton of reasons why you need to be worried about security. We live in a changing landscape for media. We used to have SDI. I'm sure you could have hacked it if you tried hard, but I don't think anyone did. It was very isolated. Why would you hack it? Some of those reasons would exist, but many of them wouldn't, right? There's no point trying to steal an SDI HD router to try and do something to someone else, right? Some of those things didn't exist. It doesn't make any sense. And so we kind of lived in this world. We lived in this world of a very, very, very isolated system. Even if you had some IP coming in, it was turned back to SDI, and it went through an SDI processing chain, and then it went back to IP somewhere else maybe. But there was no through path. There was no kind of way of stealing stuff. You had to plug something into a BNC cable, right? But 2110, and kind of most of what I'm going to talk about covers that kind of 2110-y sort of network, but it does cover everything else as well, I think. We're now in a world where we've had IP connectivity in broadcast forever. I mean, we would think of connecting to a BT BNC to send it somewhere, and we didn't worry about what it was. It was a BNC, had SDI on it, right? But no, those magic guys, they turned that into IP, and they shoved it compressed across some clever MPLS network or through a satellite, and magically it turned up somewhere else as a BNC with SDI on it, right? We didn't care, we didn't have to care. But we're not in that world anymore. So we've had this IP in and out forever, and now we've got IP in the middle. And so we've just opened up all of this clever stuff to the attack surface, to the threat vectors, which are having it connected to the rest of the internet, right? We're seeing a lot of 2110 networks are starting to really deliver the agility, the flexibility, the creativity that people were expecting 2110 to give us. Look at Discovery, Eurosport, look at CBC Canada, look at SRF in France. They're just doing amazing things. Every big network I see that's going IP for their live production, they're just doing more and more and more. The steps are huge. They're trying to do incredible things, and those incredible things are about scale, and they're about connectivity. So we're right in a world where we cannot forget about security anymore. We forget about it all the time. It's something we'll do later on, and we just can't afford to do it. And we have talked about some of these other things, but we're starting to see these close couplings between the content creation, distribution, repurposing, playout, OTT. If you can glue those things all together, you start to make savings, you start to make stuff easier, but you're also providing a target that somebody's going to be interested in trying to get to. And if you're talking about kind of normal campuses and stuff, you're in the world now of bring your own devices, IoT things, Wi-Fi, contractors. I mean, who doesn't have contractors that turn up to do the script and they bring their own laptops, or audio engineers that turn up and connect random stuff in? I mean, it happens all the time, right? It just happens all the time. And now Wi-Fi 6E, Wi-Fi 7, it's going to give us incredible bandwidth. We're going to be able to just stream stuff from our phones to the Wi-Fi point, get it on air. You're building in way, way, way more attack surfaces. So that's what I'm going to talk about. I am going to cover zero trust networking very, very lightly. Historically, we've thought about securing the network as being stopping bad people getting in and making sure that computers don't have bad software on them. That's been pretty much it for a long time. Zero trust kind of tries to move that model away from make sure nothing bad gets in and make sure the computers aren't infected with something, to don't trust anybody, give them the minimum possible access, limit the scope of everything they're trying to, that they can be given access to. So it's a much more restrictive by default sort of approach to security. You kind of, it's not about the edge anymore. It's about everything. Everything you've got to deal with everything within your network with a view of security, and it's all about kind of security postures and quite a lot of stuff. What I'll talk about coming up will kind of add to that conversation about what zero trust can be, and it's an evolving thing. I mean, zero trust has been, I guess, it's been something we talked about for a little bit, but the technologies are. We heard about AI twice already, right? So the technologies are moving on very quickly to attempt to give you this ability to give everyone the least possible access so they can do their jobs and reduce the kind of attack surface to a bare minimum. Physical security is obviously, you know, we overlook this a lot. How many of those 42 problems were caused by somebody who had access already, or who picked up a USB stick at a trade show and thought, oh, that's a nice one, I haven't got a 64 gig one. Or if it clips on my keychain really nicely. I mean, I heard a story a long time ago about at a security event, there was a guy who had a stand, and his stand was just providing people the ability to charge their phones. And people turned up and they charged their phones. And then afterwards he emailed them and said, well, you really should never have done that. I took over your phone for a little while and now I'm sending you an email because I know exactly who you are. Please, you know, don't do it, right? Don't be connecting things to other people's things that you shouldn't be. So, yeah, you should be limiting physical access. You should be monitoring and logging access. People should have keys. They should have swipe cards. You should be changing your passwords, changing your access processes. You should be disposing of stuff securely. You shouldn't be plugging USB sticks that you picked up on the floor. That's a bad thing. And you should encrypt your data. Everywhere you can afford to encrypt it, you should be encrypting it at rest, in your disks, and in flight. Particularly in terms of physical security, if you've got a bunch of dark fiber between here and there, and somebody could go and stick an optical tap on it, they've got your data, right? It shouldn't be unencrypted if it's physically in a place that somebody could grab it from you. So there's a ton of things you can be thinking about, and there's a ton of different encryption technologies out there to suit your needs. If we go back to kind of basic security precautions, so I'm going to talk a little bit about the kind of the bare minimum in my mind. I think of security as a castle, a series of hierarchical devices that attempt to allow the right people in and the right people out, but keep the wrong people on the right side of that wall. And so you've got your moat, you've got your outer thing, you've got your Bailey, you've got all that kind of normal hierarchical stuff. Firewalls, typically stateful filtering of traffic. They're typically going to allow stuff to get out, and they know what to try to get out, so they'll allow that partner traffic set to come back in. But they would typically have been kind of very north-south. Can I get in and out of this data center? Yes, you can. As data centers become bigger and bigger and bigger, you see them more often starting to be used as part of the segmentation process between east-west traffic to allow you to both create this ring of stuff, but allow you to move up and down through the ring, but around the ring as well. So from one location to another in the same sort of a business area, you may still be running through kind of firewalls as part of your segmentation process. And, as painful as it is, you want to lock those things down as hard as you can, really. I mean, if there's a thing that you don't need to go through it, you should probably not let it go through it, right? It's probably easier to allow something to go through than have the bad thing go through. Logging's been mentioned. I think, yeah, so make sure that the traffic that is going through these firewalls is being logged. If you're going to use the firewalls to be doing inter-segment routing, we'll talk about segmentation in a minute, then bear in mind that they're typically software, so make sure you've got the capacity in your routing, your firewall routing layers to do what it is you're looking to do. And you can see here a little diagram of the kind of hierarchical approach you might see. You've got an internet, you've got a firewall. So behind the firewall, you've got stuff that needs decent access to the internet, but you realize it's roughly at risk. And then you've got three firewalls in series there. You can see that the stuff that you care more and more and more about is further within that ring of safety and security, okay? You've got to jump through more hoops to get into it. And in a lot of ways, that's kind of one of the things you're trying to do, is you're trying to make this stuff more difficult. We've heard that already. If it's easy, they'll carry on. If it becomes a bit more difficult, then they'll go somewhere else maybe. So, we'll see that in pretty much every half decent network you've got. You have a very, very hierarchical series of devices that are enabling only what needs to get through and enabling you to securely connect different segments of your networks together. Yeah, the next basic thing is keep your software up to date. I mean, how often do you guys update your network routers? You should be probably doing it. You should be doing it at every critical security patch, and you should be doing it probably at least once a year. I don't know what other vendors' life cycles are. Ours is 3 years. So you probably don't want the latest software. Wait for 3 months till it's been out there and beaten to death by a cloud provider, and then pick it up. Patches, they're typically for security purposes. So if there's a security patch, you should be putting that on. Cisco's got a big problem at the moment. I don't know if they had a patch for that. Who knows? But the point is, you can go to, there's a website link, there's a link there, CVE, critical vulnerabilities. Most of anything that's a proper security problem, that will be publicly described once it's been understood and once the vendors have had an opportunity to fix it and to distribute that fix, okay? So you should make sure your vendors are, you can work out the quality of a vendor by the number of CVEs they've got. You can work out whether they're telling you about their CVEs. You should be patching this stuff as soon as you can. The example at the bottom is the Heartbleed critical vulnerability that happened a couple of years ago. I think it's SSH. There was a bug in open source SSH, been there forever. Somebody found it and they started using it. Guess how many bits of open source software have got SSH in them? Guess how many bits of kit have got open source SSH libraries in them? Ours certainly did. We built a ton of stuff off the back of the open source community. The great thing is the open source community finds it very quickly and they fix it very quickly, and it gets peer reviewed. So the ability to patch that vulnerability quickly and stop your SSH, which is your secure access to your device, from being impacted is vital. So patch stuff. Updates typically less important than the patches. They're kind of bug fixes, but some bug fixes are worth doing. So please do that. Decent vendors will be pushing their CVEs to you. You can subscribe, get an RSS feed, and you will never not know about your vulnerabilities. Build a lab, play with stuff in the lab. If you're worried about upgrading stuff, I know the broadcast world is tricky, 24/7, blah, blah, blah. But honestly, there's no excuse for not having a lab. There's no excuse for not having a playbook that says how am I going to apply a patch. There's no excuse for not having a playbook that says how I'm going to do an upgrade. There's no excuse for not practicing it on the lab. And there's no excuse for not having a 6-monthly or 9-monthly planned upgrade process for your production system. If you're not upgrading them, you don't know how to upgrade them. When you need to upgrade them, you won't be able to upgrade them. I do know a customer who's running code that's about 5 years old because they've never done it and it's a bit scary, don't want to do that. Well, fine. but it wouldn't be me. Limit access to the network resources, change default credentials, disable unwanted features, telnet, unencrypted, turn that off immediately. Ping, oh, that's really handy. I love my ping, but it's a tool that once somebody's got into your system, they can ping and probe and do all sorts of things. So yes, very handy, but you might want to turn it off in the more vulnerable areas of your network. You should have individual logins as a bare minimum. I know plenty of customers who've got a, admin Arista login for their network switches. Wow, mental, please don't do that. Have it for while you're building it by all means, but very quickly you need to move to something, individual user logins as a bare minimum so that you've got traceability, but ideally something like AAA, which will allow you to, authentication, authorization, and accounting, right? Allows you to identify who is trying to connect to things, what is it they're allowed to do, and what did they do. I'll talk a little bit about that in a minute as well. And if you can, configure some role-based access control. So different users get different levels of access to your network. They can do different things. Some can just look, some can look and change. This is all standard stuff, completely standard stuff. There's nothing here that an IT guy isn't going to go, why am I talking about this, you're thinking, right? Because it's stuff that we don't do. It's just stuff that is not getting done, okay? But it's all there, available to use. And limit access to the control plane of your network devices. Stick those management ports in a VRF that is not connectable via your front panel ports, and apply. I'll talk about it in a minute, Steve. It's a virtual routing and forwarding concept. So when you take a switch, you can chop it into different VLANs, and they're like different layer 2 things, and a VRF is taking a router and chopping that into different routers. So the two routers can operate independently. They can't route between them unless you try hard, and they can operate on the same same address space, but it's completely separated. So you can put your management system into a routing plane that is can never be got to by your data plane. So if somebody's hacked into your data plane, they can't necessarily hack into your network control system. And you can apply ACLs, access control lists, so you can tell the switch from where it can be controlled. So if it doesn't come from 10.10.10.0/24, I'm not going to listen to you. And you can apply similar sorts of concepts to the users. You can enable them to do different things. So how are we doing so far? How am I doing for time? 20?
20 left.
Oh. 10 minutes left. Whew, got loads of slides. Networks, are we okay so far? Everyone doing all this stuff? Everyone should be doing this stuff. Network segmentation. Anyone want to guess what that's all about? So segmentation is when you... I asked ChatGPT what segmentation was. I got a lovely answer. Well, now ChatGPT knows that I'm interested in network segmentation. I imagine I'll be getting a lot of adverts. So it's the practice of dividing your network into smaller segments, which can be isolated or not. But my example is a bit of a noddy picture I stole off the internet, and it just shows VLANs, right? But the concept is perfect. If you can slice your network, and we've seen that they're converging, we've seen there's loads and loads of services on them, people are doing lots of stuff on their networks now. If you can slice your network up into separate chunks of network, because they do different things, or they're managed by different people, or they're running different services, then you have the ability to kind of reduce that attack surface. You can limit that lateral motion. So if somebody gets into the green bit of the network, they may not be able to get into the blue bit of the network, okay? So you're trying to make it more difficult. You're trying to create boundaries where bits of equipment in one segment can talk to other bits of equipment, but they can't talk to things further away. And as networks become more complex and you start to build multi-tenancy networks where you're carrying multiple different independent tenants worth of data, so you may have a 2110 multicast underlay, you may have a internet tenant, you might have a contribution tenant, you may have a distribution tenant. They can all live in the same physical network, but you don't want them to talk to each other. You don't want the kiddie channel showing the Formula One, right? So you want to segment your network up to prevent those things from happening. And there's a lot of ways you can do that. In our 2110 world, we've got -7, so that's a physical segmentation, the red and the blue, right? That stops the A channel and the B channel from running across the same well, it prevents them from not being diverse, okay? We have a physical diversity built in. The VRFs we talked about, you'll often find routers have been sliced into multiple VRFs, and that means that they can continue. It's just like taking lots of routers and shoving them together, but they'll operate separately and independently, and you can't leak data between them. It's a software concept. You've got to trust the software, but it's been around for a long time. Encapsulation, VXLAN, MPLS, GRE. These are techniques where we take traffic and we stick headers. We further segment them, and we kind of the super inner headers are now headers which allow the switch to understand they belong to different tenancies and to treat them differently. Again, software constructs, but they could allow you, for example, to build multi-tenanted infrastructure where you're running many services across that. And if you don't need those things to be able to talk to each other, then you should stop them from talking to each other. Layer 2 domains, I would argue, in the kind of world I work in, I want to see the smallest broadcast domains humanly possible, because multicast is a very bad actor if you get it wrong. So what you don't need is UHD 10 gigs of traffic spewing all over the place. What you want is a lovely /31 endpoint. So it's then perfectly segmented. It cannot ruin anybody else's day. It can't create broadcast traffic that upsets people, okay? SDN, what a great, software-defined networking. We're seeing that in 2110 worlds all the time. But that's actually a really great way of securing your network. You can't get the wrong multicast in the wrong place unless you tell it to go to the wrong place. So I see it as a security tool, to be honest. And then macro and micro segmentation. I'm not going to go into those too deeply, except to say that it's a way of programming the forwarding planes of your switches to do something other than following exactly what the destination MAC and destination IP addresses are telling them to do. It's a bit like SDN. In this diagram here, the yellow things are allowed to talk to each other, not because they're in the same VLAN or the same IP address range or the same VRF, but because microsegmentation has said that they can talk to each other. Some external devices told them they can. Network access control, NAC. I've got a diagram that tries to tie this all together, but when you plug something into the network, let's say it DHCPs itself an address, so it's plugged itself in, it's got an address. You kind of want to start working out what it's allowed to talk to. So in a modern data center or a modern enterprise environment, you'd have some form of network access control. And what that does is essentially when that thing fires up, it starts talking, and it talks to a network access control system. And that access control system essentially stops it from being able to do anything. It automates the quarantining of that port until it's worked out what that device is supposed to be doing. What's it supposed to be talking to? Which segment is supposed to be in? Which tenant is it supposed to be in? And that data will come back from its back-end system, fed by lots of other things. And it can then provision the port on the switch to put that device in the place it's supposed to be. And that can be, it can be as complex as the NAC then goes off to an identity service like OneLogin, and it says, well, what is this guy allowed to do? Well, it's allowed to be in this address range. It's allowed to talk to these things. It can be in that tenant, and it can access these services. It can be as fine-grained as you like it to be. It can also be as simple as you like it to be. It could be based on importing a list of MAC addresses in a spreadsheet and saying, these are the ones that I'm going to allow onto my network. And if I see one that isn't that, you're going to shut that port down. So we don't really have much excuse in our world. I mean, we have a lot of endpoints that are bespoke endpoints that don't run a lot of software stacks, but that one there is an absolute bare minimum. We could do that every day of the week. Now, that stops me moving my camera. Well, build some processes in that you can move your camera then maybe. I don't know. And it does a lot of other stuff. Endpoint assessment. It will look at the security posture of those endpoints. It will analyze if it's running DHCP, it will snoop on that. It'll look at the data set that DHCP is providing it and the LLDP data set, and it will be able to identify from that things like, is it running the right OS version? Has it got the security patches I wanted attached to it? Is it running the antivirus that I want? And if it isn't, you can shut them down. So there's a lot of complexity here, a lot of moving parts, but most enterprises are doing lots of these things already. I talked about enforcement, I talked about quarantining. That's the scary one for us, right? We don't want the camera to be quarantined, but maybe we just have to start doing some of these things and start working out whether we can trust them, because they're bits of IP, the same as anything else, right? I mean, they're running an OS the same as everything else. They're definitely hackable. So maybe we should think about that. So I wanted to put it into context, and I'm afraid I had to steal a marketing slide, so ignore the marketing bits, but you can see the bit in the middle, Agni, that is that's the NAC, that's the network access control device. And you can see it does essentially sit at the core of this process. It talks out to all of the identity services. It's potentially listening in on all the DHCP traffic, it's snooping all that stuff, it's doing all this profiling, it's running all sorts of, it can be listening in on the 802.1x stuff. It's sat there, it is the gatekeeper of what is allowed onto your network. So you have to trust it, and you have to give it enough data for it to do its job. But everyone's got one. We've got one, Cisco's got one, Forescout's got one. There's a ton of them out there. There'll be one in this building. I mean, every single one of your enterprises will be running one of these things at some level or another. And I think as we move in the 2110 world towards less bespoke hardware and more servers running software, there's no excuse for these guys not to be in the same world, really. So I've only got a couple more now. How many have I got? Plenty or 5? Okay, a few more minutes. So as we move up the stack of things you could do, we're definitely out of the basic stuff now. This is now advanced stuff, and it does play into some of the stuff that we've been talking about already. So network detection and response, it's an active way of analysing what's going on in your network and determining whether there's something you should be worried about. And simplistically, it's an advanced version of IDS, intrusion detection services. And its job is to look at traffic in your network, get to that bit in a minute, and to analyse whether that traffic is right or not. And it does it, I can throw some ML in there and some AI in there, but essentially it's learning from lots of other systems, and it's learning from your system what is the normal traffic. I'll give you an example. And it doesn't need to decrypt the traffic. It's looking at the security posture of the device, and it's looking at the sorts of characteristics of the device and what the device is trying to do. So an example would be, I've got a bunch of CCTV cameras, and they're all talking to the discs over there, or the recorders. Well, that sounds normal. Yes, that's okay, that's fine. But then I find one of them that's talking to the email server. Well, that's probably not fine, right? That could not be a good thing. So it's looking to see what the relationships are between devices in your facility, and it's trying to work out which of those relationships may not be right. Typically, you have a team of people, and they're analysing this stuff. You're building models. You're telling it what's normal. You're saying, "Oh yeah, thank you for telling me about that one, but that is okay. You can learn from that. These sorts of things are fine. Let them do that." We've got a great example. The company was losing, well, basically somebody was trading against the company's stock, and they couldn't work out how it was happening. And it turned out a grumpy employee had brought one of those illegal USB sticks. They plugged it into the Polycom, and they stuck some software on the Polycom, and the Polycom had then been configured to record all the board meetings and to exfiltrate that somewhere else. And so there was a guy at the other end of it, sitting trading away on board meeting results, made a fortune. But it was only when a system like this was able to say, well, hang on a minute, you've got 50 Polycoms, and none of them are talking to Russia. So probably that's not a good thing. So these sorts of systems, you can never use one of these for 2110 traffic. 2110 traffic is also multicast. I'm pretty sure that using multicast as a vector for hacking stuff is going to be tricky. But you do have a ton of control plane traffic. You're configuring endpoints. Those endpoints are reporting. They're doing all sorts of clever stuff. They're definitely hackable. And you could definitely use a system like this, not to worry about the heavy-duty 2110, but to worry about whether your control planes are good. So that's network detection response. How would I use that in my system? You would, it needs to get data from somewhere. Typically, it gets data from agents that you install on things or from taps that you deploy around the place. So in this particular model, we're using mirror ports maybe, or optical taps in the network. We push that all up to a packet broker. Packet broker is essentially it's a series of switches programmed to filter and then send traffic in the right places, not based on IP addresses, but based on where we want them to go. So we mirror a load of ports, we send it to a monitoring fabric, and then we push that out to the NDR system. And then the NDR system's then got all the data it needs to be looking at stuff that's happening in your network, trying to analyze your network. The nice thing about this packet broker monitoring thing is you can hang other stuff off it. It's just a thing that takes the traffic from somewhere and pushes it to tools. So we have tool ports and we have monitoring ports, if you like, in this sort of a network. And in our world, maybe we want to Wireshark some traffic to see whether it's looking good. Maybe we want to send it to EBU lists to analyze whether it's good traffic. Maybe we want to stick it into a WFM, but we don't want a WFM stuck on every single one of these switches. So why don't we mirror it and send it through one of these networks? So there's a ton of stuff that normal IT, IP workflows can bring into the sorts of media networks that we're building. We're not doing very much of it. We should definitely do more of it. So I left it for my last slide to say security should not be left as an afterthought, but it so often is left as an afterthought. And the thing is, it's also not something you can do once, because the world moves on. You add devices, the security threats continue to evolve. You've got to keep on the top of this. EBU's done some good work with its R143, which tells you what your endpoints should probably be doing and how you should be using security for how those endpoints should behave. You can see the triangle. The red bit at the bottom is it, embarrassing that security. That's the stuff that in the 2110 world we haven't got to yet, and that's more shame on us. The JTNM did some great work on TR1001. That talks about encrypting traffic to and from ISO4 repositories and the like, and using DHCP and doing some good things. So there is some good work out there. I'm not going to go through all of these, but essentially security is always going to be a compromise between the maximum security you could possibly apply and the level of operational simplicity and flexibility you need to achieve. And that'll be different from everybody. But the basic stuff that I talked about, the first 3 or 4 slides, the basic stuff should be the bare minimum, really. You shouldn't be having people randomly logging into Arista networks. That's just a bad thing. You can build as many other bits and bobs on top of this as you like that suit what you're trying to get to. Start by working with your security teams as you build your networks, and they'll help you. They genuinely want to be helpful. They don't want to be the guys that at the end that are just crossing stuff off because it's not the way they want to do it. Ask your vendors to adhere to endpoint best practices. I mean, we're in a world where we've got lots and lots and lots of very special endpoints, but we can all do better. There's a lot of open source stuff out there. There's a lot of Linux-based boxes. They could all be using a lot of this stuff, and get some training and build a lab. And I think that was me.